one from the images to robot1 images. When I only start publishing the results, you will see that the publisher starts sending the data and the machine learning service starts the processing, and the result listener will obtain the results from the machine learning service and writes the result or the obtained message back to the console. We can test one more thing, that if I change, for example, if I change the topic name in the result listener to robot 0, not the robot 1, and run the image publisher again with the previous settings, so you can see that the image publisher is publishing the data, machine learning service is processing the data, but in case that we have incorrect topic, that the data goes only to the topic they came from the image publisher. So they are not published to every topic, but the communication is dedicated based on some identifier. Okay, let's move on to a little bit more complicated example. And before start of this part, it's necessary to take a look to the communication interface between robot and the machine learning service, which is defined in this 5G-ERA machine learning control service interface. So we will see in this example that the machine learning control service has like 5 services prepared. One, then we have a start service, which is responsible to generate the unique task ID, or the in our case the UUID, and it will create unique data input results, output topics, and return the generated identifiers back in the response. There are a little bit more parts of the message for the start service which are not used in these examples, but they are important for some more complicated services. We have created even the stop service, and for the stop service, the robot in the request has to send the task ID, which is the generated UUID by the start service. And for some further more complicated machine learning services, such as, for example, object detection with the movement evaluation. We have services for setting and getting the internal state of the machine learning service, and even for the restart of the internal state. but these are not used in during this workshop. So in this example, we can start use the real object detection machine learning NetApp in a standalone variant. And for the purpose of this workshop, this service is implemented with a simple face detector from the OpenCV library. And the output of this object detection service is the bounding box around the people's face. And for completeness of the answers or the messages back to the robot, this service also returns the class of the object and the detection score. In this example, we will launch the standalone machine learning service, which has implemented the ROS2 control service server, and it's processing the response. And we will simulate the robot by calling the ROS2 service, using the ROS2 service call to the start service, and we will request the control service server to generate the unique topic IDs and to create a dedicated node for these topics. And after that, we will run again the image publisher and result listener, but with this generated topic IDs. So this part of workshop simulates the call which should be done by the robots to the machine learning service. We will start the machine learning service from the ROS2 5G-ERA object detection standalone package. And before we do that, we can check the ROS2 service list. Okay, I think that it's maybe running from some. Yeah, it's there because it's defined in like the interface is defined for the service, so we can start the machine learning service. We can see from the output that the detector thread is running and the control service is running as well, and it's waiting for the requests. So we can simulate the robot behavior and complete the ROS2 service call to the machine control service start service using the ROS2 5G-ERA service interfaces, and we will use the start interface. So if I finish this service call, you may see that the node with generated task ID was created, and that it was starting, and that it was started. And if we check the ROS2 topic list, you see that we have this topic created. Yeah, there is probably something, some task running in the background because we have like more topics than we should have. Let me check it first. Yes. Yeah, I know, because they were not destroyed. Okay, never mind. This should be only in my computer. You should see only the parameter events and the ROS out probably. So I will start the service again and do the service call, and after that we are able to start our image publisher from the basic example, and the original image topic will be remapped to task ID data topic, and for the result listener it will be the same, but not data topic, but the results topic. Again, you can see that the image publisher is publishing the images, the machine learning service is processing the data, and they are getting back to the result listener. Okay, this is what I said before, that the control service server inside the machine learning service node is generates the unique identifier for the task, launches a new ROS2 node with dedicated image subscriber and the result publisher objects for this task, and creates this nodes. And I have idea what is causing us that we have the topics here. So let me fix it for now. Okay, so back to the workshop. And the next part should show us the standalone machine learning service inside the Kubernetes cluster. So in this part of the workshop, we move from the host system with the machine learning service and deploy the standalone version inside Kubernetes. And we will use the micro Kubernetes in this workshop, and which should be already prepared in your workshop virtual machines. If you are if in that case that you are not using the virtual machine, but if you are using your host system,